Hello everyone, my name is Mohammed Noor Al-Awad, a researcher and a PhD student from ITMA University, Russia. Today I'll be presenting our work, a multimodal conversational agent for tabular data analysis, prepared with my colleagues Sergey Ivanov, Olga Tikhanova, and Ivan Khodlenko. So the focus of this study is to enable more natural interaction with data and to allow users to analyze tables and datasets through conversations rather than traditional coding. So as we know, manual coding in environments like Python and Pandas remains a barrier for many professionals who need to explore data but lack programming skills. At the same time, voice and language-based interfaces are becoming more common, which shows a clear potential to simplify analytical tasks. So our motivation here was to design a system that provides an intuitive data analysis process, which helps like domain experts and managers query datasets directly in plain English or any other language, whether through text or speech, without relying on technical tools. So at the beginning, we examined several existing approaches that connect natural language with data analytics, and found out that some commercial tools such as Tableau, Power BI, and other tools, they support like text-based queries, but do not perform actual code execution or reasoning. And on the other hand, voice-enabled systems such as QLink Sense and similar ones show potential multimodal features but lack conversational continuity and transparency of code. Our approach extends these ideas by combining dual input modalities with grounded code execution and adaptable response modality, which aims to bridge the gap between accessibility and analytical depth. So here we see the core architecture of our conversational agent. So the system coordinates several components: an LLM for reasoning and code generation, a speech-to-text engine for voice input, and a text-to-speech module for generating spoken responses through audio synthesis. So each user query, whether typed or spoken, is first normalized and combined with dataset metadata to form a structured context. So the orchestration layer then decides whether the query should trigger a conversational answer or the generation of executable pandas or Python code. So when the code is produced, it runs inside a controlled sandbox, which enforces like safety limits, for example, no operating systems, no network access. And on the other hand, if the request is conversational, the system instead produces a short natural explanation suitable for speech synthesis. And of course, after each run, the agent updates its internal states so that it will allow follow-up questions and remain aware of prior steps. This will like maintain continuity and support multi-turn dialogue over the same dataset. And here we summarize how the system uses prompt engineering to manage dialogue and maintain consistent behavior. So each user query passes through three prompts. So the first prompt is a decision prompt, which is like a classifier. It classifies the user's intent as either code generation or conversational response. It reproduces a structured JSON output for deterministic routing. So the chat response prompt generates short, natural, and TTS-friendly text when an explanation or clarification is more appropriate than like computational code. So the code generation prompt, on the other hand, produces minimal executable Python code without like comments or other print statements, for example. So it ensures it runs safely inside our sandbox. And to make outputs context aware, the system dynamically grounds each prompt in schema like metadata, statistical hints such as like ranges of the values or sample values, and the recent conversation history, of course. So together, these elements promote determinism, faithfulness to the uploaded data, and safety while keeping responses concise and speakable for voice interaction. And here we see an example. So this example shows how the system maintains dialogue continuity across multiple user turns. So the first request asks to plot charges versus BMI. The next adds like color by smoker status. This is an example of one dataset. And finally, a regression line is requested. So each new query builds on the previous one without like restating the full context. So the agent remembers the dataset, the prior steps through like conversational memory. This design allows users to iteratively refine their analysis in a natural step-by-step way, which is pretty similar to how analysts explore data interactively these days. And yeah, for the speech interaction, the system integrates two open sources, which are Whisper for speech-to-text and Coqui TTS for text-to-speech synthesis. So Whisper was selected for its low word error rate of around 4.8%. It has also strong multimodal support and open MIT license. So it reliably transcribes user input into text with the latency of under 1 second for like average length query. And for audio output, Coqui TTS synthesis do the synthesis of spoken responses with the natural tone and low delay, about 0.3 seconds for 10 words, which is pretty real time. So it provides a good balance between quality, openness, and performance, which is a very good angle to enabling smooth and realistic conversational flow during data exploration. And to evaluate the system, we designed a benchmark covering 48 natural language commands across 3 public datasets of different sizes and complexities, which are listed here, like the auto group product dataset, the student performance dataset, and the US flight dataset. So each of these datasets, we designed 16 representative tasks grouped into like visualization, analytical queries, and then narrative like categories. So examples here range from creating scatter plots, calculating feature maxima, to like summarizing relationships between variables. Yeah, so, and of course all these experiments were executed on our infrastructure. We used for this experiments, we used only one GPU, NVIDIA RTX 6000 ADA. Also on the server we had like a Python-based sandbox environment to ensure like consistent and controlled evaluation across models of varying sizes. Yeah, and for the model evaluation and selection, we compared the 5 instruction-tuned models. We used the Qwen family for its popularity these days. So yeah, we compared the models from the Qwen family ranging from 1.5 to 32 billion parameters using the same benchmark and environment. And of course, as expected, performance increased with the model size. So the smallest model was 1.5 billion. It shows like pretty bad misclassification and limited reasoning ability, while the 3 billion variant already achieved like good results. While the 7B model provided the best trade-off between like accuracy and latency, reaching about 96% overall correctness. And the 14 billion model slightly improved results to nearly 98, but with like noticeable higher computational cost and latency. So yeah, and generally execution errors were rare and primarily related to sandbox restrictions, which is good actually that the restrictions are working. So average model only latency, so the latency of only the operation related to the model was around like 1 point something, which is between 1.1 to 1.6 seconds, which is acceptable for interactive analysis scenarios. And here's a demo. Let's have a demo of how talk to data prototype works. Hi, how are you?
Hello, I'm just a helper ready to assist you. How can I help you today?
Can you please plot the charges versus smoking status? Can you please make this plot bigger? I see that usually the smokers pay more.
Yes, the data shows that smokers generally have high charges compared to non-smokers.
Could you please plot the charges per smoking status across age groups? And are there any outliers in the charges column? Finally, what do you recommend other things to do with the data? Can we like plot something else?
Certainly. You could plot the distribution of charges across different regions.
Yeah, okay, please do so. Hi, how are you? So yeah, so the prototype demo demonstrate how a single conversational loop can turn a spoken questions into an interpretable results. A user can issue a voice query, the system grounds it into dataset context and executes the generated code safely. So this will help in producing both visual output and spoken explanations. So each step remains transparent. So the Python snippet is visible, reproducible, and audibly summarized. And beyond research, such an approach has several applications. It can serve as a voice-driven analytics assistant for like managers and educators. It enables like accessible data exploration for visually impaired persons. And also it supports interactive teaching of data concepts, and it can be embedded into dashboards or like notebooks for like hand-free analysis of data. And it also provides a practical framework for conversational insight generation in data-driven research environments. So looking ahead, our next steps focus on extending the orchestration framework and strengthening the reliability. So we plan to integrate additional tools such as image describer and insight summarizer, uh, probably support multi-session conversational memory and move beyond like tabular data toward unstructured modalities. And from a technical standpoint, we aim to introduce like self-correction for generated code and to enhance sandbox execution through like micro virtual machines or containerized execution. And equally important, we care about the ethical and the user-centered aspects to ensure like local and encrypted data processing. We also want to enforce strict resource guardrails to prevent misuse, which we did partially for now, and we want to enforce this. And of course, conducting a user study will be very much appreciated to evaluate trust, like usability, and of course, the cognitive load of the user. So these directions together aim to advance the system toward a safer, more transparent, and of course, more inclusive conversational analytics platform. And to conclude, for now, we built the end-to-end agentic architecture that enables natural interaction with tabular data through voice, and text. So the system supports dynamic switching, like on-the-fly switching between visual and spoken outputs. It executes analysis like safely in sandbox, and it remains transparent through visible code that is editable. And then we evaluated the system or the prototype on a 14.8 command benchmark, which covers like multiple dataset types and achieved around 68% using an average model, 7B Quinn model. Another thing is that the framework relies entirely on open source components, which emphasizes reproducibility and extensibility. So, in broader terms, this work contributes to democratizing data analysis through accessible speech like driven tools and promoting transparency and educations. And this, of course, this work should offer a foundation for future open, multimodal, and trustworthy conversational analytics systems. So, yep, that's it. Thank you all for your attention.